In this video, I'll be giving an example of using the PERT technique for project scheduling to find out the project duration and various other information. So the basic difference between PERT and the critical path method is we are given three time estimates. Because PERT is generally used for non-routine projects where time is probabilistic as we are not certain of the time. CPM is generally used for routine projects in which we have one single time estimate, that is time is deterministic, and we are confident about the time that each activity takes. But we are not confident about it in PERT, so we take three time estimates. As you can be seen here, optimistic time, most likely time, and a pessimistic time. So the first step in PERT is drawing a diagram and finding the estimated time for each activity. So we don't directly use all three times in the initial part. We take a single time, the estimated time. So for that, we just take a weighted average of these three time values. So the estimated or expected time is simply optimistic time plus 4 times most likely time plus pessimistic time, the whole divided by 6. We can calculate this for each activity and we get these values. Now, for most part, the critical initial part for project duration, the PERT method is similar to the critical path method. We can draw the sim network diagram similarly in activity or node method. As once you got a single time, it's similar to critical path method. So in case you have not seen my earlier video of critical path management, do check it. In that I've shown how to solve a question of project management, project scheduling using activity or node format, which is an easier and more common method of depicting project scheduling diagrams in the present time period. But in case historically and in cases of many books, you may still see activity on arrow format, and many times for PERT, you will see activity on arrow diagrams. So for this question, I will be illustrating using a activity on arrow format instead of activity on node. So in case activity on node you want to see, and many times it's simpler, do see my previous video on critical path method. Once you have a single time estimate for the initial part for finding project duration, it will be a similar part thing. But for the remaining part, in case you have activity on arrow, as you can see here depicted like this, from event 1 to 2 activity A takes. So this notion is for the activity on arrow format, which many times you will see in books and various other sources, especially for the PERT technique for historical reasons. So this video I'll be showing on activity on arrow format. So how to draw activity on arrow? So if you see a question like this using 1 to 2, 1 to 3, this is a notion that is the activity on arrow. So first, seeing the logical sequence, draw a network diagram. You'll see here. As you can see on the above, I have shown a network diagram. Just see the logical sequence, draw this diagram because it will be very helpful. Activities are shown on the arrows, not on the nodes, and with the duration we have calculated. So as you can see, A is 13. This is shown here. Now coming to finding out the various times of the activities estimated for early start, early finish, late finish. This is similar to how we did in critical path method too in the activity or node. Basically, we do the first the forward pass, then the backward pass. So in forward pass, we go from beginning to end. We use the early start time to find the early finish. If you see here, see the network diagram. A and B happen in the beginning. They're the first activities to start. So what is the early start time of it? Naturally 0. They're the first two activities. So the earliest they can start is time 0. They're the beginning. Now what about activity C? C, as you can see in the network diagram, begins after A is ended. So as I mentioned, first we'll also use early start times to calculate early finish times. So for activity A, earliest start is 0, duration is 13, means earliest it will finish is 0 plus 13, which is 13. Similar for B, 12. Now C can start whenever A finishes, as you can see from the network diagram. So its earliest start is 13. D, if you see from the network diagram, can begin whenever uh, B is ended. So its time will be 12. earlier start. Similarly, you can calculate for these two the early finish, 13 plus 2, 15. If early start of C is 13, it takes itself 2 weeks to happen, so 15 weeks. Similarly for D, 20. For E, in case of E, as you can see, E can start whenever A is ended, again 13, and this will become 28. Now for F, F depends on two different activities, C and D. There's a convergence. As we discussed in convergence, even in the previous video, critical path method, we have to choose between the two of the larger values. That is, F can start after both C and D are over. D is 20 weeks. That means this will be 20. Because F can only start after both C and D have completed. In 15 weeks, when C completes, D is still going on. So I have to wait for D to complete till 20 weeks. In 20 weeks, both C and D are completed. That's why earliest F can start is 20 weeks. Its own earliest finish is 20 plus 2, 22 weeks. And this is, we are over with the forward pass. Now we go with the backward pass, we go reverse. So we start in the end and go to the start. We use the latest finish time to find the latest start time. It's a reverse order. So in this, what we will do first, look at the last activity. The last activities which start, the last event. If you see, it's in 5 is the end. So E and F. Activity E and F are the last. So what is the latest finish time of them? Naturally, E, as you can see, this is also the project duration, 28 weeks. The whole project is complete in 28 weeks. E, when completes, all is over. This is the project duration. So naturally, E can latest finish us as 28 weeks. There's no scope of delay. F, there's still time. It can finish in 28 weeks because 28 weeks is the time the project is ending. F can finish earlier 22 weeks, but there's a scope. It can finish at 28 weeks too. We assume the latest finish of the last event as 5 as part of backward pass to be the project duration itself, which is 28 weeks. Now we go reverse. We have the latest finish time here. We can easily use this to find the latest start. 28 minus 13. This will give, so this will be 15. So in this case, it will be 15. Uh, in this, not 15. This will be 28 minus 13. So minus 15. 28 minus 15. So this will be 28 minus 15. So this will be 13. And similarly, this will be 26. So like this, we can continue solving this. So now that we have got this, now see the next one. So we have done for E and F. So now we can see C and D. So when is the latest finish time of C and D? C and D have to be ready for F to start, as we had seen. So when F finishes, that is the latest. So in other words, as we can see here, the latest C and D can finish is the latest time F can start, because F depends on C and D. As you can see from this network diagram, F, the latest it can start is 26 weeks. That means C and D should be complete latest by 26 weeks. So I can do 26 here for both of them. And here it will become, again it will become 24 and it will be 18. So on, we can similarly see the logical relationships and calculate all. So just to show, to summarize this overall, this process, we get these values in the end. To try calculating it on your own, see the logical relationships, and you will be able to continue using this logic as I mentioned, the forward pass and the backward pass. Now simply that we have got the activity durations, we can use to find the float, the total float, which is simply the time we have that a project activity can be delayed without delaying the entire project duration. It's simply LF minus EF, or latest finish minus early finish, or LS minus ES, which is latest start minus early start. You can calculate this for each activity to get these values. As you can see, certain activities, namely activity A and activity E, in here have zero float. That means they have no scope of delay. These two are called critical activities. There is no scope of this to be delayed. So at part A and E, as you can see above in this diagram, this top A and E, this is the critical part. The part which goes to the activities which have zero float. They are important to look at because if they get delayed, the whole project will get delayed, unlike others which have some scope of delays. So in this case, now if we want to know what is the probability of finishing a project in a specific time, we did calculate the project duration just now as 28 weeks here. So how was this 28 weeks? We found out the whole activities is all activities are ending at 28 weeks, but this is based on the estimated time. Naturally, we just talked that PERT has three time estimates. Maybe all activities happen in the best case scenario, the most optimistic time it will finish earlier, or it could happen in the worst case scenario. This was just an estimate. What will it happen if it gets delayed? So for this, now that we found the critical part, we have to come back and find the variance of activities in the critical part. As you can see, this is the formula we use for finding the standard deviation of the activities in the critical part, and by this we can find the variance. The two critical part activities A and E, we take them, we can find the using this formula, which is pessimistic minus optimistic time divided by 6. We can find the standard deviation, and squaring it we get the variance. If we sum this, the first step is we find the standard deviation and the variance of each activity. Then we find the standard deviation of the critical part by finding the square root of the sum of variances. The square root of the sum of variances of the activities in the critical part. This gives us the standard deviation of this project. Now we have two values we just found. One is this project is finishing in 28 weeks according to the expected time, and its standard deviation is 9.43, is 3.07. So in this case, once we have got this value, we can simply use the Z tables to help us find this value. We assume that this project has a normal distribution. The mean and standard deviation follows a normal distribution. That is true for many projects as they have a lot of activities. And when they have a lot of activities, we can assume that it will follow a normal distribution, its mean and standard deviation of timings. So in this case, we simply take, as you can see here, the specific time we want to check. Like if we want to check, can this project, which we just found out will usually happen in 28 weeks, what is the chance it can finish earlier in 25 weeks? So basically we do is the specific time period we want to check minus our expected time duration divided by the standard deviation we just calculated. We get by this the Z value. Now using the Z value, as it can be seen here, this was minus 0.977. As you can see here, this is the Z tables. We can look in it, the minus 0.9 as you can see is in the end. This is here is my for minus 0.907, 0.1160 almost, approximate this, which is 16%. So by this, we can find out the probability that our project will finish under or over a specific time too. So this is just a general formula you should know to find out the Z value. Once we get a Z value, we can see the Z tables to find out what is the probability of having that particular Z value.